Hello, in this video we're going to create a geocoded table from a shapefile. Now let's open the shapefile first and we'll talk about what a geocoded table is and why we want to do that from here. We're going to use Manifold Viewer because Manifold Viewer is the free edition of Radian Studio. Anything that Viewer can do, Radian can do, of course. But Viewer is, like I say, is read-only, and anybody can download your Viewer and use it for free, so it's convenient to use it in video demos like this, so anybody can follow along at home if they like. Let's import the shapefile. File, Import, and here we're going to click on the shapefile castles_France. Click Open, and that imports the drawing. If we take a look at the drawing, we see that it is, let's click View, Panes, Info. In the Info pane we can see it's pseudo-Mercator. That's not the projection we want. Shapefiles often do not come with projection information, so let's specify that the initial projection here is latitude and longitude. And Radian knows so many different projections, it's the only way to sort through them all between the thousands of EPSG and thousands of standard is to use this little filter button here that restricts the projections that are shown to only those that match the characters in the filter box. We want latitude and longitude, so we're going to click that OK. Great, so the drawing is now correctly imported from a shapefile in latitude and longitude projection. If we click open the table, we see that there's an index field, there is a name for each object, and there's a geometry object, which is just points. Quite often, shapefiles won't have a latitude and longitude value. So, strictly speaking, this table sort of is geocoded because there's a geometry, a point for each. But applications like, say, if you want to output this table so you can use it in your GPS device in the car, they need a latitude and a longitude field. They can't just read geometry no matter, because a lot of applications don't understand geometry format, even if you use a well-represented standard such as well-known binary or well-known text. And what we want to do is we want to add a latitude and a longitude field here. So let's do that. Let's click this button here, and first with latitude, and we'll make that float 64. Add field. Let's click again, and let's do a longitude. Let's make sure we spell that right. Click again, float 64, add field, and now let's populate those fields. That's easy to do using the so-called transform dialog in Radian. The transform dialog is a point-and-click dialog that here in the list of pre-built templates populates templates for whatever type field we have. So if it's a name, which is a var character, there's all these different templates that have to do like replace text or regular expressions match that works with text fields. We want to populate the latitude field, which is a float 64. And to do that, we're going to use not a pre-built template, but we're going to do an expression tab. And the expression tab allows us to write any sort of free-form SQL statement that we want. And instead of writing a free-form SQL statement by hand, we are going to copy and paste. I've copied off screen this value, this text, which I've gotten from the create a geocoded table from a drawing example topic that's in the Radian user manual. We just literally highlighted that in the user manual, copied it and pasted it in here. And what we are doing here is we're using the Geocoded XY function. If we want to see what that looks like, we can paste it here in the filter box, and that'll show us all the different operators and functions, SQL functions from that list that have this text string in them. And we want Geocoded XY, which extracts the XY coordinates from the geom field, and then the vector value function grabs the second one of those. This is zero-based numbering, so that's the latitude. And Radian will preview the results of what it proposes to do here in blue color. And if we like what we see, we can click Update Field. Great, we just did the latitude. Now let's do the longitude. I'm going to click longitude here, and here I'll change the number to 0 because we want the first of the XY values. Longitude is in X direction, it's kind of left and right when you look at a map geographically. Latitude is Y direction, that's up and down. And that too looks about right, because those indeed are the longitudes at which most of France is located. So let's click Update Field. And we're done. We've just created a latitude and longitude. We've just created a geocoded table that has, for each record, a latitude and a longitude field. Just for the heck of it, while we have all this open, let's play with the drawing a bit to see where all these things are located. Let's create a map. To do that, I'm going to create a data source to use as a background map, which we will call streets. And we will use the Bing Map Street Map server. Create a data source. Now let's create a map. The map has multiple layers in it, so we can drag and drop things into it. And let's click open the map. It starts off being empty. Let's drag and drop the Bing Map Street Map image into it first. And now we'll drag the Castles France drawing into it. You can see they all appear here correctly, georeferenced in France. I'm going to change the color on those so they stand out a little bit better from the drab default gray style. Let's use a bright orange color. There. That's fun. And the amazing thing is how you can be driving around in France and have no idea that you've just driven past a really cool a chateau or castle that's hidden in the woods. I'm going to do one more thing here. I'm going to create a new data source that shows a satellite image. Call it satellite. And we're going to make use the Bing Map satellite image for that. Create data source. Let's drag and drop that into the map. Click that off for the moment while I zoom in. Let's zoom in here just south of Bonneval, which is on the road south from Chartres, between Chartres just south of Flacy. And if you zoom in here, you can see where that road goes by. There's a lot of woods right here. So along the road you see nothing but woods. And right here there's one of those insidious speed cameras that the French use to automatically record the speed that you're going. Most people have their attention focused on that speed camera. But right here, they don't realize is a really cool chateau. These things are all over France. That's not a particularly good image. Let's take a look at how Bing shows that image. Excuse me, how Google. Call it Google Sat. So Google Maps satellite, create data source. One amazing thing about Radiant technology in Viewer, wow, look at that. Now you got to admit that's a lot clearer than Bing Maps. In some places Bing Maps has better imagery, in other places Google has better imagery. In this case, if we click this off and on, we'll click off the Google satellite to see the Bing. Now we'll click the Bing. You can see that Bing shows that castle, shows that chateau way better than rather Google shows it way better than Bing. And that's part of the fun of using Radiant Studio and Viewer is that you can find all this stuff and you can use all this data sets. Viewer, like I say, is free. It is read-only, so once we've created this geocoded data set, we really can't save it from Viewer. If we want to save it for use with some other application, we'll have to have done all this in Radiant Studio. But it's not like Radiant Studio is expensive. It's typically under $300, sometimes as low as $245, depending on the deals that are being offered. So that's certainly a nice tool to have in your toolkit. And if you only want to take a look at something on the fly and see where latitude and longitude are for, say, some particular point, some particular object here, a particular chateau to enter into your GPS, well, you can do that in Viewer. You don't have to spend any money at all. Anyway, thanks for watching, and goodbye from Radiant Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.